Suppose you have Justine and her little brother Evan, and they're running a race. Because Evan is younger, Justine gives him a 50-foot head start. Evan runs at 12.5 feet per second, and Justine runs at 14.3 feet per second. How far will they be from Justine's starting line before Justine passes Evan? And what distance should Justine mark for somewhat of a closer race? So first thing I'm going to do is I'm actually going to start a table that describes the relationship between time, Evan's distance, and Justine's distance. Here's what I notice. At time 0, Evan is already 50 foot ahead of Justine, and Justine is starting at 0. After 1 second, since Evan runs at 12.5 feet per second, Evan will be at 62.5 feet. And since Justine is running at 14.3 feet per second, Justine will be at 14.3. After 2 seconds, Evan will be at 75 feet, and Justine will be at 28.6. Now, I notice there is a relationship between time, Evan's distance, and time and Justine's distance. So here are my two equations. The first one is for Evan. The equation for Evan is going to be y equals 12.5x plus 50. The 12.5 is because Evan runs at 12.5 feet per second, and the plus 50 because Justine gave him a 50-foot head start. For Justine, the equation is going to be y equals to 14.3 x plus 0. I really don't have to write the plus 0, but I am going to write the plus 0. Right? Keeping in mind that y represent the distance and x actually represent the time. Right? Now, since Justine runs faster than Evan, eventually she is going to surpass Evan, and we would like to know what time would that be and what distance is that from the starting line for Justine. So I'm going to go ahead and graph these two equations on the next piece of paper, or the next slide here. I'm going to let time be on the x-axis, and I'm going to let distance be on the y-axis. I am actually going to start the time at 0, and I'm actually going to do a scale of 2. Now, you'll notice that I didn't have anything on the negative side of the x-axis. The reason is because we're talking about time, and time cannot be negative. Now, same thing when we're talking about distance. If we're talking about distance, it really doesn't make sense that the distance is going to be negative. So therefore, I'm also going to start distance at 0. Okay, so you notice that I'm using the scale of 2 for time. I'm actually going to use a scale of 5 for the distance. So every box that you see on the y-axis represent 5 feet. So 5, 15, 20, 30, 40, and 50, 60, So for Evan, he started at 50 and he's going up by 12.5 per second. So what that means is he's going up by 25 per 2 seconds. So 25 would make him at 75. And that's the line for Evan. Now for Justine, she is starting at 0. So let me put her first point at 0. And she's running at 14.3 feet per second. So every 2 seconds, she's at 28.6 feet. So I'm not going to be super accurate, but it's going to be somewhere about there. So let me connect the dots here. And this would be the line for Justine. Now, at some point, Justine is going to surpass Evan, but I'm not going to be able to see that from my graph. So what I'm going to do is I'm going to use a different method to find that intersection for Evan and Justine. And that method is going to be called by substitution. So what happened is, you'll notice you have y-equal equation for both Evan and Justine, and at some point these two y values are going to be the same because that's the intersection point. So what that means is Evan's equation and Justine's equation is going to equal to each other at that intersection. So by substitution, what I'm going to do is I'm going to drop the y and set the two equations equal, substitute the two equations to equal to each other. So here's what I'm going to get. 12.5x plus 50 should equal to 14.3x. So at the intersection point, their y's are going to be the same and their x's are going to be the same. So I am going to solve for x first. I'm going to combine the two x's together by subtracting 12.5x to both sides of the equation. So on the left-hand side of the equal sign, I'm going to get 50 equals. And then on the right-hand side of the equal sign, I'm going to get 1.8x. To undo that 1.8x times x, I'm going to divide both sides by 1.8. So x is going to equal to approximately 27.78 seconds. So after about 27.78 seconds, Justine is going to surpass Evan. So that's part A. How long before Justine will surpass Evan? For part B, what I would like to know is, what is the distance when Justine will pass Evan? So the distance, I'm going to use Justine's equation. After 27.78 seconds, the distance is going to be y equals 14.3 times the time, which is 27.78 seconds. So after approximately 397.25 feet, sorry, had to think about the unit there. After about 397.25 feet, Justine will surpass Evan. So you'll notice that on my graph, because of the scale that I'm using, it's not possible for me, just using this graph, to go up to approximately 400 feet. Of course, I can certainly do that if I change the scale. Okay. So the intersection point is going to be at x equals to 27.78 and y is going to equal to 397.25 approximately. Okay, this method is again called substitution. here's what I would like to do. I would like to go back to the previous examples that we have done.